All right, ladies and gentlemen, we'll start now. I hope that you're here to learn about business intelligence and data warehousing. If you're not, you're in the wrong room. But don't leave, please.
You mean this is not Alcoholics Anonymous?
No, sorry. Maybe Techies Anonymous or something if we're all geeks. Okay, so one question I have before we start, is there anybody in here who doesn't do geek work as their day job? Good, excellent. Apart from the two that I brought. What I'm here to talk to you guys about is that everybody who's in IT, every one of us here, we're really in the service organization. We're here to serve those people who are on the business side. It doesn't matter what kind of a company you work for, if you're actually in an IT department or if you're in an independent software company that produces software, whatever you're doing with them, you're actually serving somebody else. Okay, and that's the way I'd like you to take a look at that when we're taking a look at business intelligence and data warehousing. You're here to give somebody else some information and make their job easier to do. And if you think about it, that's exactly what you do during your day job. So just to start, this is me, and I just gave you one link up there. You should be able to find everything you need about me up there. I'm an MVP. I've got a couple things going on in the community, but this isn't about me. This is about data warehousing, so we'll just dive right in. So why are you here? Well, hopefully you read the blurb that I made up the abstract, and it asked a couple questions or put a couple things forth that are interesting to you or you want to find out more about. So one of the reasons you could be here is because you know from what I said in there that business intelligence is in demand. Over the last decade, research groups like Gartner and Forrester, when they've asked and done surveys, CIOs, CEOs, one of the top things on the list, almost always in the top 3, has been business intelligence. And it's been there for the past decade, and it's not yet going away. So everybody wants it, and it's up to you guys and everybody else to kind of understand what it is. One of the reasons, you may say, okay, well, that's fine. It's on the top 10 lists of a bunch of these surveys. Why is it there? What makes it so important? Why do people do business intelligence? What value does it have? And what's the big deal? And you might just be here just because you want to learn what it is for yourself, either because maybe you want to do that as part of your job because your boss has said we need to do this, or because you're coming here to figure out what it is because you may want to do this at some other company or change jobs or whatnot. So we'll answer the question about what is business intelligence data warehousing. I'm going to put up a couple quotes from Wikipedia here about what BI and DW are. They're informative, but they're very technical descriptions. And the important things that I think you can pull out of this, especially the BI one, is the word business, understanding, and context. That's what it's all about. It's about getting the business to understand where it fits in the world, what's going on with it, and how it can better survive and profit from what's going on. So saying that doesn't sound a lot like technology, and really it's not. The end result, which we're going to use this for, is very business oriented, and it should be. Some of the ways we deliver that is through technology. A data warehouse is one of the better ways to provide this business intelligence, and you rarely see the term business intelligence without data warehouse somewhere very close by. And depending on who you ask, sometimes they're exactly the same thing, sometimes they describe different things, but they always tend to be complementary. I have a little definition for business intelligence and data warehousing, and it's about empowering just about everybody in your organization with some kind of insight or information to make better decisions. Because for me, this is all about making better decisions. You can have a whole bunch of data, and that's great, but if it doesn't help you to make a better decision at work about who to sell to, what price to sell them your product at, and all that kind of stuff, it's really not helping you too much. So it's a lot about decisions, and it's a lot about even stuff that tech guys have probably heard. You've heard at one time in your life the phrase, the right product to the right customer at the right price, and they can go on and on with about 15 different rights in that sentence. And that's about the problem that business has, is that they need to find out who their right customer is. They need to find out what the right price to sell their product is. They need to find out when they need to sell it, where they need to sell it, and all this other kind of stuff. And they use, or they can use, data to get them there. But the problem is that a lot of the data that they're getting is very raw. It's coming from OLTP systems. which is your line of business system, which isn't really formatted for a business user to digest very well. They have a hard time getting at that information. So I wanted to take a little short break to kind of tell you what I'm thinking the difference between data and information is. So has anybody here been to Pittsburgh? No? Phil? Okay. Do you know, if I wanted to get to Pittsburgh, where would I go? And I'll tell you that this is a sign that's just outside of Pittsburgh. It's pretty complicated. There's absolutely no indication where Pittsburgh is. The only reason I know it's outside of Pittsburgh is because, does anybody want to guess what I had to do in order to find out where this sign was? No? I've actually never been to Pittsburgh either. I found this picture online because I was looking for confusing signs, but if you had to find out where you were from this sign, what would you do? You would probably have to do what I did and go to Google and figure out where some of those streets are, Steuben Street and some of those highways, and figure out where they intersected. So this sign all by itself is practically useless. It doesn't, unless you already know where you are and you know where you want to go, it doesn't help you at all. It's got a lot of data. There's no denying that. But it really doesn't have all that much information. If I was going to Pittsburgh, I would want that sign. Wouldn't you? Okay, so the point I'm trying to make with this slide is that context and simplicity are better delivery vehicle for information than just data. Okay, I'm going to relate it a little closer to business data here, and this is probably this kind of thing that a lot of you have seen. It's a big spreadsheet with numbers on it, with current year sales for a bunch of customers and margins and previous year's sales and budgets and all kinds of stuff like that. And it's a big spreadsheet, and it's way too much to see on one screen, and half of you probably can't read it. I'll blow up one little part of it there for you. That's all nice, but that's data. If I asked any one of you to find me a problem with a customer in there, it'd be pretty hard for you to do. In fact, one of the questions that I would have as a business person looking at this data is that you can tell from a couple of the examples up there, the people with high sales I've got lower margin for. Basically, that's your economy of scale at work. The more that somebody buys off me as a business, the better price I give them, right? Because they've got a little bit of that purchasing power, and they can go to my competitor and get a little better price out of them. But the guy who comes off the street and doesn't buy very much, doesn't have very much power over the price that I give him. So that's kind of something that I expect to see in the data. But I also have to watch out as somebody who's running a business to make sure that I'm not charging somebody too much. Because if I charge somebody too much, they may go to my competitor. I have to make sure that I'm not leaving money on the table. That if they're not buying enough from me, maybe I'm not charging them enough for that privilege of doing business with me. So in order to find that out with this kind of data, you would have to actually manually comb through it all and understand what all the numbers were and read it, and it would take you a long time. Instead, if I showed you this, you can pretty easily see a pattern here that this is kind of that inverse relationship, and there's kind of a line, and then you got this guy right here who's floating out in the middle of nowhere. I may not be able to see from this visualization what the problem is, but I can tell that there's something unusual about this. And now I can start to take a look into it. So this is what I'm saying is sometimes less can be more. In fact, on here, you should be able to see I've got percentages down the left side. That's the margin, and I got dollar sales down the bottom. Those, in fact, aren't even necessary. You don't even need to see those to know, to be able to spot the pattern that doesn't fit. Okay? And that's the whole thing, is that people, humans, are good at spotting patterns. There's no pattern in that text data that's up there. None. There's nothing you can pull out of it. But from a chart or a graph or visualization, there's a lot that you can do to help a human automatically spot what shouldn't be there or what needs further investigation, at which point they can drill down. Okay, so that's kind of a carrot as to what makes business intelligence good. Some of this visualization that you can get with it that immediately highlights what's out of place or where you might have to direct your attention. It gets rid of some of the noise. This is the stick as to why you should probably be doing it, or at least considering looking into it. just like we did on the past couple slides, we spent a lot of time wasted trying to figure out where to go from that orange sign and what that data meant from that big spreadsheet. And 62% of professionals that were in the survey that I looked up had that same problem. They described that, well, we waste a lot of time looking up this information. We sift through data and we try and turn it into information. How much is a lot? 1.7 hours a day. So if you translate that into a working year, depending on the size of your organization and depending how many professionals you may have in your organization, that could be hundreds of thousands, millions of dollars wasted because they're looking for information. I'm just going to see what we're doing, how we're doing on time to make sure that I'm not going too fast or too slow. Okay. So that's a cost that's borne by you. The BI market and data warehousing market is maturing. It's consolidating. People like Cognos are buying Hyperion, and Oracle buying Cognos, and Microsoft buying Vertipack, and there's a whole bunch of consolidation going on in the industry. And one of the effects for you guys who may be looking to do business intelligence and data warehousing is that costs are coming down. That has another effect as well. But and because they're integrating, their tools are integrating as well. You're getting end-to-end solutions from a single vendor. Their tools are starting to work together. I think that a lot of them still have a long way to go, but that's a benefit for you. You really only have to learn one thing, and then you can kind of get a flow. And as this improves, as these vendors integrate their products even better, there's going to be less of the little knobs to turn and things like that. It's going to be less complicated. The effect of that is going to be that business intelligence is not going to be a competitive advantage anymore. It's not going to be the few who want to get ahead of the pack that are doing it. It's going to be everybody's got to do it to stay with the pack. If you're not doing it, you will lose. It's not that you won't win. You will lose if you're not doing this thing. And it'll take a while to get there. But sooner or later, this is going to be a cost of doing business, and everybody's going to have to do some of it in order. So that's the stick. So when we talk about BI as the part of the business intelligence and data warehousing, business intelligence is usually what the users interact with. The data warehousing is the plumbing underneath. At least that's the way I take a look at it. So we're going to talk about BI applications, and some of the things that we see there, some of the words, the buzzwords that you may hear about are dashboards. Does anybody have a dashboard in their company right now? Okay. Does anybody have a scorecard? Yeah? It's a balanced scorecard. You know what a balanced scorecard is? Okay. A lot of these things, the dashboards and the scorecards, are kind of interchangeable. They're a little specific in different areas. But what both of those things do is they expose some of those numbers up front, and sometimes they can be as bad as getting that big spreadsheet just full of numbers. But when they get better, they start to use some of those visualizations that let you immediately see that there's something out of place or there's something wrong. A scorecard adds some more information to a dashboard in how it relates to trends or to a budget or to expected numbers, a target, and tells you whether or not you're on target or whether you're off target. That kind of thing, it can be pretty powerful from the top of the organization to the bottom. At the top of the organization, the CEO and people like that can take a look at how's my organization doing as a whole, pull all that information together and see, you know, is it my revenues that are on target, my customer satisfaction on target? And you can push that kind of a methodology all the way down to the guy who's sitting at your sales desk and give him a scorecard which says, have I made as many calls as I'm supposed to today? Have I, you know, got as many orders as I'm supposed to today? Some of this, what you really want to be able to do is to give him feedback about how he's doing his job so that he can see, is there anything that I can do to make sure that whatever I'm doing at work is contributing to my company? If they don't get feedback like that, then they make decisions on their own. And some of that, almost all those decisions are on incomplete information. There is almost no such thing as making a decision based on complete information because you never have it. Okay, so if you let him develop his information for himself, he may be making decisions which aren't aligned to where you want your company to go. And I'm throwing in some very bad business buzzwords about aligning strategy and stuff like that. But you know, really that can be what it's about, and making sure that everybody who's working in the company is working towards the same goal. It goes on to some business applications like data mining and real time and the DSS there is for decision support system. Who's shopped at Amazon? Probably everybody, right? Or even Chapters. Down at the bottom, whenever you're taking a look at a book or you've got stuff in your shopping cart, one of the things you always see is people who bought these things also bought these things. Right? Has everybody seen that kind of thing? Netflix has the same kind of thing. That's only in the States. That's business intelligence. They know that people who made the purchases that you're about to make also made some other purchases, and they want to make sure that you're aware that they carry these things to try and impulse you into an impulse buy. They want to try and get as much money out of you and help you buy more product. Right? That's what Amazon's trying to do. They can't do it by just throwing random products up on the page. That's just like, you know, the banner ads and stuff, and everybody ignores those anyway, right? If they target them, if they take a look and they know a little bit about who you are and what you're doing there and what you're buying, then they can throw something more relevant up there, and you probably appreciate it. You know, you like that to some degree. You might be a little concerned about the privacy aspects of it, but I mean, probably everybody appreciates, oh yeah, I really do want to see that. I really do need this. Netflix just had $1 million prize. Does anybody know about that? The Netflix $1 million prize? Netflix rents videos in the States. There's a couple services in Canada that do the same thing. But basically what it is, it's a subscription service. You give them, I don't know, 10, 20 bucks a month or something, and you have a list of videos that you buy from them or you rent from them. You make up a list and they'll send them to you in the mail and you watch them and then you send them back. It's not like going to a video store where you pay $6.50 or $5 or whatever it is to get one video out at a time. It's a subscription service. So you can watch as many videos as you want as long as you get them out of the mail, watch them, and throw them back in the mail. 10 videos a month for maybe the price of a single video rental from a store. It's an intriguing concept. But one of the things which they do is the same kind of thing as Amazon. They've got, as you're making up your list, oh hey, those movies that I see on your list, if you think you're going to like those, or if you rated certain movies highly, I think you're going to like these ones too. The difference there is that they've got nothing to sell you. They've already got you on the hook for their subscription service. Okay? They make these suggestions because they want to make you a happier customer. They don't want you to leave. That's some customer retention activity they're doing there. What they did is they said, well, we think we have a pretty good engine, but we want a better one. We want one that gives more relevant results. And so what they did is they said, anybody who can give us more relevant results than we currently give our customers, 10% better. That's all they want. 10%, we're going to give you $1 million. And they called it the Netflix prize. And there was a couple people who actually won it a couple months ago. All they had to do, I mean, if on average you take a look at your, this is what I want from Netflix, and there's a couple recommendations at the bottom, and if half the people added one title to their list, that's a 50% success rate to Netflix. And all they wanted to do is knock that up to 55%. That's it. And they'd give you $1 million. Of course, it took some real mathematicians and data analysts to figure out how to do that, but they did it. And that was worth $1 million to them, and it got them no more sales. None, zero. Didn't translate directly on the bottom line or anything, and they were willing to pay $1 million for it. It was all about getting a better customer experience for them so that the word of mouth would spread. It's all about that business value, and in that case, it was intangible. So some of the things, some of the stages that you would go through to develop that kind of thing, that's a pretty advanced application. Is the first thing that you need to do with BI is to do that monitoring. You need to know where your company is at right now, and I'm talking about things like consolidating information from a bunch of different systems that you might have in your organization. Your ERP, which is your line of business system that, say, does your sales and enter sales orders in. You may have an inventory system, a payroll system, who knows what else. You may have a clickstream from your website, and you want to see how people are surfing through your web and do some of the stuff that Google Analytics does. Getting all that stuff in one place and getting the single version of the truth. Who here has heard of that, the single version of the truth? Okay. It's a big thing in BI, getting the single version of the truth, because what you can get is when you've got all these different separate systems, and you may even have a copy of a system in a couple branches, and each branch may run their own system. Maybe exactly the same system, but they just run different instances of it, like you run different SQL Server instances. They may create a report which has a certain title on it and has certain columns on it, but displays completely different data than what another branch has produced. even though they call it exactly the same thing. And then you get some of the executives or some people trying to make comparisons from one part of your company to another, and they're trying to pull this together, and the numbers don't line up. And then you get into a big argument when you get into meetings about this is what this number means, and you can't solve anything because nobody can agree on the foundational information. So that's something that data warehousing business intelligence is good at, very good at. That's one of the typical goals, is to get that single version of the truth. So that's what the monitor stage is at. You need to know where you're at. You need to know some financial information consolidated all together. After you've gotten comfortable with that, then you can get on to analyzing that and trying to get a lot more information out of it, rather than just collecting data and getting some dumb reports out of it. You can start to get trends out of it. You can start to do some what-if scenarios. Try and find some relationships between data points inside your own information. Then you can start to make some plans. You can put some budgets in there. You can start linking it to external data, to housing starts, to the interest rate, to the consumer price index. So you might be able to see, is my company business linked to broader economic factors, and how seriously is it linked to that? If we have people predicting that the housing market is going to go up or down, is that good or bad for me? Should I be preparing to add capacity to my company, or should I be preparing to lay some people off? The sooner you make those decisions as somebody who works in a business, the better your business will be. The more you can accurately align your company with what's actually going on in the marketplace. So that's something that's pretty important when we're talking about business intelligence. So some of the things that we're going to talk about now are success factors. If you're going to go and do BI and data warehousing and you don't have it now, what are the things that you need to do? How many think it's technology? The correct answer is it's not technology at all. There was a survey done by the BI network, and they asked a whole bunch of people who have BI, and they said, what were the critical success factors? 12 of the 14 answers they got had nothing to do with technology, nothing. It was about getting a commitment from the business, making sure that they wanted this, making sure that they were behind it, getting executive support. Sometimes they call that a sponsor or a champion. Somebody from the business side who said, I can't get the information that I need in order to make better decisions. I can't tell where my company's going. I can't tell where other companies are going. Because you can do that with BI too. You can collect some information about your competitors and plug that in and try and figure out what they're doing. So you need executive support. You also need to manage expectations. This is not a silver bullet. Everybody won't get fancy graphs on their computer to look at every morning. You're going to have to work at it a little bit, just like even if it was a regular line of business system. You don't start out with a full-fledged thing right at the beginning. You build at it. And actually, that's the better way to go about it. If you try and do one big thing, you're going to get pushback from the users. You're going to get them saying, well, I used to do everything this way, and that was comfortable. Now you told me I have to throw that book away and have to do everything this way. I don't believe you. I'm going to go back and do it this way. But if you ease them into it, you give them a little more information over time, and then they start to use it, and they'll start to see some value in it, and they start to hear from other people, hey, I used this piece of information that I got out of our BI system, and it helped me do this better. And if you keep your ears open, you can hear that and then broadcast it to the rest of the organization. Say, this guy from over here, don't believe me, don't believe what I tell you, believe what he says. He's a part of the business. He's not part of this IT leper colony that we got going here. He's part of the business, and he knows what he's talking about. You don't believe me, but believe him. He said that he got some value out of this. So maybe you should go talk to him or see what he did and try and use this information to help you. And then maybe if there's something that he did and you want to take it to the next level, then come see me and tell me what more you want. Because the one thing that I know about business people, as soon as you show them a report that has anything to do with an analysis, they look at it for about 5 minutes and they go, you know what, that's interesting. And they throw it in the garbage and they go, but what I really want to know now that I knew that is this. They're always evolving. They're always taking a look at the information they have and they go, well, that's great, but now I need to know this. Now that I know that was great, but now I need to know something more. And they'll keep doing that. They'll keep churning through that information and consuming it and changing the way that they're looking at their organization to ask different questions. That's what part of BI is about too. About setting these incremental goals and going at it a bit by bit so you don't get that massive pushback from the business because you're changing the way they're doing things. You have to be a little viral at it and get at them slowly and get them to adopt a different way of looking at information, and a different way of making decisions even sometimes. Sometimes you'll have managers or executives who aren't used to taking a look at actual data to decide whether they should do something. They just do it with their gut. And that's the way they've always done it, and it's worked for them. They may be leaving money on the table and they don't even know it. They may be leaving costs on the table and they don't even know it. They may take a look at your information that you've presented and go, yeah, that just confirms what I already knew. That's fine. The odd time that information which you present to them, they may look at it and go, that's not what I think is going to happen. I think something different is going to happen, but at least it will raise that question. They'll start to say, some of the information you're collecting or the way you're presenting it or the questions that you're formulating with your information aren't right. Or maybe their assumptions are incorrect and what you're actually presenting to them is the truth, and you're going to help them out and actually help them make a better decision. Because nobody's perfect. Right? So we're really here for technology. What does this mean on technology? Well, the two things that did make that list of concerns of the critical success factors was an integrated platform. People didn't like to go this place for this answer and then another place for another answer. And it makes sense. People want to go to one place and get those answers. And a lot of vendors are starting to do that. Microsoft is trying to shove everything into SharePoint through their whole stack. Cognos has a presentation thing, and well, that's part of IBM now. And so they're integrating this stuff, and they're getting all the tools all together so that they work nicely together, and you can get them in a format that users want to consume. You can get business intelligence information on your BlackBerry, delivered in real time, alerts, and all this other kind of stuff. And the second thing that was on there was investing in BI skill sets. So you had to make sure that the people that you were asking to do this kind of analysis for you and build these reports and find the information for you were actually able to do that. They knew what they were talking about. But one of the things we're going to go into next is trying to let you know why some of the things that you might be doing today won't work if you try and deliver this. So we're going to talk about OLTP database problems. Now, who doesn't know what an OLTP database is? Okay, everybody. Well, that's good. OLTP databases have a couple things that make them really good for transaction processing, but those things that made them good for that make them very bad for analytics. You can still do it. I'm not saying you can't. And in fact, there's a lot of tools out there that will bolt right on top of your OLTP system and use the data that's in there to do some BI. In my opinion, that's a mistake. One of the things that's very strong about an OLTP system is the fact that it's normalized. Everybody here should know what normalized means. It means that pretty much if you've got a piece of data sitting in your database, it's only in one spot. So that if you have to change it, you only have to change one place. The reason for that is to make your database ACID so that it's atomic and consistent and durable and all that other kind of stuff. But basically in layman's language, that means you want to change as little as possible and be as fast as possible changing it so that everybody sees that change as soon as possible. Because you may have 10,000, 100,000 users hitting that system, and if you need to make a change, for example, at your bank balance, everybody needs to know it immediately. Right? You can't have that waiting or locking a big portion of your database so that nobody can do anything while you're updating a bank balance. That would grind the bank to a halt. Not very scalable. But that's a problem in analytics. I'll tell you why in a second. The other thing that you find with OLTP databases is that they are designed for random access and they're update oriented. It's there to make updates for. This is something that you do in your line of business. So you're adding invoice line items to an invoice, changing a customer's credit limit. You're doing all these kinds of things. You're updating information. Sure, you're getting information out, but a big part of an OLTP system is being able to update data. And you could be updating that anywhere in your entire database. So you could be doing it for customer A, and then for customer B, and then Z, and then you got 10,000 users doing this all at the same time and tweaking little parts of it. And that's where normalization helps you as well, because each little tweak takes a very short amount of time. So all these people can get in there and they aren't in each other's way. Another thing that tends to happen in OLTP systems, because it's normalized, is that you tend to use the whole row of whatever table you're looking at. If you're entering a sales order line item, you're going to be plugging information into just about every column in that table because you're updating that row. I'm not saying that you're always going to use the whole row and you're always going to be updating every column on that, but that's what tends to happen. That's almost the exact opposite of what tends to happen when you're doing analytics. So what do we do in analytics? Why do these things get in the way? Well, the first thing is that analytics, we're taking a look at huge data sets, history. And we're taking a look at this usually, we're reading it off the disk anyway, in sequential order. We're looking at all of 2009 sales. We're not looking for a specific line item on a specific invoice. We're taking a look at all this stuff for all customers. We're taking a look at a whole bunch of stuff. Okay? And we're usually only looking at a couple columns at a time. We don't care about how much was in taxes or what the customer category was, perhaps. We're just interested in the total sales, so that extension line on your invoice line item. Okay? But we want to collect them all. So if you've got them arranged, in a normalized fashion, even if there aren't many columns left in that table, there's a whole bunch of columns you're not using in that query, but that your database server still has to read off the disk and pass through memory, even though it's completely a waste. You're not going to use it. Analytics almost always use history. And that's sometimes something that's not even kept in an online transaction processing system. In your line of business, history information is not terribly important. You may have it in your OLTP system now, but that's because you're trying to make it do double service. You're trying to get some analytics out of your current line of business system, which you probably shouldn't. But really, when you're putting in a sales order, do you need to know what they bought last year? No. You may need to know their credit limit, their current balance, how much inventory you have in stock, but you don't need to know what your inventory levels were for the past year. That's just not relevant information. And in fact, it gets in the way because if you try and store all that information in your OLTP system, that's a whole bunch of data. It could be 95% of the entire data you've got in your system that's simply not used, except for random queries here and there for somebody runs. Well, that gets in the way of all these 10,000 users trying to get in there and poke some information and change it and maybe run a tiny little extract out of that. Okay, because every time you've got to maintain these massive indexes and age splits and all that kind of stuff can completely get in the way and drag down your OLTP system. When somebody runs a report and they're looking for this sequential information about all this history, are they going to be nice to the transaction system and let it continue to carry on? They may monopolize 2 or 3 processors on your 8-way box that now can't be used for managing your regular line of business system. So trying to put a BI solution on top of your OLTP normalized system can really kill the performance of your current system. Another thing that we do in analytics is we do comparisons. I want to know the top 10 customers last year or last month. I want to know the top 10 customers from last month, and are they still the top 10 customers this month? Typically what that means is that you're going to have to make multiple passes over the data. So you've just asked your database server to do something incredibly complicated, well, not complicated, very simple, but with a lot of data, and you just asked to do it twice. So you're not even just hitting it once, you're hitting it twice. The other but major difference between an OLTP system and an OLAP system is that when you're doing analytics, the whole idea of it is the data. Users use the data. When you're talking about a line of business application, users don't use the data, they use the system, and the system goes and manipulates and extracts the data. They've got somebody in between. And that's why you've broken it up into so many bits. It doesn't have to be understandable to a business user. The business user needs to know how to drive the program, the application that's on top of it, or the applications, but they don't need to understand the data in the back. In fact, you'd rather they didn't. You don't even want them to see it. You put stored procedures and everything. You don't even want the developers to see it. You put all this stuff in the way so that it abstracts the data so that you can, if you're a DBA, move stuff around and change columns and add some views and do some other stuff to deal with the performance. You don't want people relying on the structure of that data to get anything done because you may want to change it later. And it's broken up in this normalized format, which is not very easy to understand. Is there anybody here who's used surrogate keys in a database before? Okay. Is that easy to understand? To diagnose when something goes wrong? You have to join a whole bunch of tables together so that you can kind of understand what's going on, because you've got basically a code is the key, and the code is meaningless. So in order to understand why the inventory record for a certain thing is below what it says in the warehouse, well, now you need to go look up this code in a bunch of other different tables, and you may need to do a lookup from there and a lookup from there and join a whole bunch of tables together before you get something that's consumable. In order to do that, you have to understand the structure of your entire database and that snowflake or spider web of relationships and keys and all that kind of stuff that's going through your data. A business user can't do that, and we shouldn't expect them to. Okay? In business intelligence systems, the users are using data, they're not using a system. And they want access to the raw data, a lot of times. So the things that make a data warehouse different, we talked about normalization in an OLTP model. We're going to denormalize in a data warehouse, a dimensional model. It's called a star schema, and a dimensional model takes those things that we want to add up. Sometimes they're called measures. They're really numbers. They're like dollar values or order counts or quantities. Those are the things that business users want to add up or get the average of. We'll put those together in a table, and we'll call that, they call that a fact table. Then you take all the things that describe those transactions, attributes sometimes they call them, and you throw that in dimension tables. And those are the things where a business user will say, I want to know all of the sales, and that sales number, those sales dollars, that's a fact. And then they'll follow it up with, for 2009. Well, that 2009, that's a dimension. For North America. For my bike product group. Right? These are things that they use to filter the information, to slice it and dice it, and to figure out, to narrow down on what they're looking at. So when we model things, when we take away that normalization, we put it into a denormalized star schema, we arrange it like that, and what a star schema is, it's got that fact table in the middle, all the numbers, and then it's got just one level deep around it, information which describes that, which allows you to filter. You may have a customer filter, a customer dimension table. This allows business users to understand what's going on better than having to traverse a schema tree that may be 5 or 10 levels deep in order to find, I want North America, but North America is the parent of the United States, and the parent to that is, the children of that are a whole bunch of states, and so now I've got to join all these 3 tables together. That's a highly denormalized format, which is very good for an online transaction processing setup, because if you change a state name, for whatever reason, you only have one place to do it. When we're talking about data warehousing, it's mostly read-only. This is not line of business information which we're using to record information in a real-time basis most of the time. There's real-time BI, but we won't get into that. That's a special case. It's mostly read-only. You're doing analysis on this huge bunch of data, huge sequential reads, and it's mostly read-only, which allows us to take a couple shortcuts. We can pre-aggregate some of this information to get answers to the user a little quicker, because we know it's not changing. It may change at defined times, say overnight, and then we just recompute the aggregates. Could change at the end of the week. You may load the system from your online system at the end of the week, and then you just recompute the aggregates. Some systems, for example, Microsoft Stack will do this kind of on the fly for you. You don't have to consciously maintain aggregates to help answer questions better. You can have it do it. It's kind of like the index and query tuning wizard. It'll help you set those up. And then there's something else called the column store database. Now remember when I was talking about how we're usually taking one number, one fact, and we're adding it up against the hundreds of thousands or millions or billions of records. And usually there's going to be some other information that are in each of those rows that we really don't care about. That's incredibly inefficient in an OLTP system when it's normalized and structured the way it should be, because you're pulling in all this data that you don't need and having to push it through the CPU to aggregate it and do all this kind of stuff. There's another way of storing that information. Instead of row-based, it actually stores it in columns. So you got one column in each file. It bends your brain a lot trying to think about the data that way, but it actually works really good. Has anybody here heard of Power Pivot from Microsoft in Excel 2010? Who knows of the 65,000 row limit in Excel, 2003 and below? Okay, that pisses off, quite frankly, quite a lot of business users because they like to get data out, and it's usually more than 65,000 rows. In Excel 2007, they increased that to what, 4 billion? 4 million, something like that. The problem is that you don't have enough RAM on your machine to pull in that much data, right? You just can't do it. Microsoft just made a column store in-memory database, which is a plugin for Excel called Power Pivot. It will let you load billions of rows and do analysis on it on a netbook, simply because of the way it's able to store that data. And all it has to do, for example, if you want the sales numbers, that extension on your invoice line item, that's all it reads from the whole file. So all you're reading is those numbers, and then it can aggregate those and makes extremely efficient use of memory because it's not carrying around the tax code for that line item, whether or not it was a freight or whether it was something else. It's filtered that out already, and it's just pulling in the values, what it needs to actually aggregate. So it's incredibly fast, and it's incredibly memory lightweight, being held in a column store. But it's very weird. As far as anybody who knows databases, it kind of goes very against the grain. So those are the kinds of things that are different in a data warehouse. Some of the way that the structure, the data is structured in this star schema rather than a snowflake. And then even some of the underlying technology is completely different, because the way that we're getting at it and what we're getting out of it is completely different from an OLTP system.
Why do you think it's more efficient to read Alabama in a million rows rather than number 10 in a million rows?
Versus a number 10, it's not. But it's more understandable for the business user. What we're talking about here is if we have a dimension table, and let's say it's your customer dimension table. So it describes all your customers. And in a data warehouse, that table will be highly denormalized. In fact, there may only be one table instead of maybe 10 or 15 that you'd have in your regular line of business application. Okay? And what will happen is on each one of those rows per business entity, and in fact, there could be multiple rows per customer, because that customer can change over time. We'll get into, we may or may not get into that depending on whether you're interested. But regardless of that, you'll have across that row stuff that means attributes that mean something to the business user. You'll have the state, and instead of just WA for Washington, you won't even have just that. You'll have Washington, the full text. You may have a char 30 space taken up by that. It's an incredible amount of space if you're talking an OLTP system. If you're talking OLAP, that's actually cheap. The reason why it's cheap and the reason why it's good is because even if you got that on one customer, you got the state, and you've got it for every single customer, and you're taking up that space, your customers table is going to be relatively small. Could be 100,000 records. Okay? It may grow over time as your customer changes and you need to make new versions of these customers. But the reason why it's okay to store that is not just because disk is cheap, because it's really not. It's because that data doesn't get updated. Hardly ever. It gets updated every night, or it gets updated every week. One of the things that you need to store that code and then a lookup table for a state, part of the reason is so that you can just update the name in one spot. But the other reason is because if you want to change a customer's state, it's got to happen really quick. Okay? You don't want to have to change on 10 customers if they all belong to the same parent company, the state at which they operate of. You're going to have to select those and then replace this big long character string every time you do it. But with a data warehouse system, you're only going to be making those changes in mostly offline hours. And it's not a question of being ACID anymore. You don't have to make sure that that change to a customer is made instantly so that somebody who's pulling a report gets it completely correctly. Now, why is completely correctly not an issue when I was talking about the single version of the truth? Well, because it was right yesterday. The state which they were in was right yesterday, and if you're going and making a change, even if it takes a second for your system to go through 100,000 records, and I don't know what system would take that long, to go through 100,000 records and update one field, chances are, there's a couple assumptions that you can make. One is your OLAP system is not as heavily used as frequently as your OLTP system. Your OLTP system, just about every single person in your organization has hooks into it, and they're running quick little queries all the time, updating here, updating there, quick little things, and they're locking and doing all this kind of stuff. Your OLAP system has longer running queries by fewer people. Okay? And so there's less time for them to get in each other's way. And even if you're halfway through making a change to a customer, through however many versions of records they have, it's usually not going to be an issue. And even if you lock that table or lock those rows in order to make that update, even if it takes a second, you're going to take an OLAP query that took 5 seconds and made it 6. Okay? As opposed to an OLTP system where 1/10 of a second may be too long, because you're dealing with 10,000 users, and having 1/10 of a second lock on a table could cripple the ability to scale out that system. It's usually much less of a problem with OLAP. In addition, OLAP's a little easier to scale out because you can just make a copy of that data, make another server, and you don't have to manage a bunch of concurrent and transactional replication and all this other kind of stuff between the two, because you can update one and go to the other one and update the other one. It's more forgiving in that respect. Okay? But the real reason why we do it that way is for the business users. They understand Washington. WA, yeah, that's probably okay for a state code. But actually, in a data warehouse, you probably have both. WA for state code for those reports that they wanted to put that on where they wanted to abbreviate it a little, but the full name on other reports where they would want the full name on it. You give them both. When yeah, go ahead. That's another really good point. What we're dealing with is consolidated data. You may have a global company. So WA may mean something completely different if part of your company operates in Europe. They may have no clue what that means. And especially not if you're dealing with codes, which are numeric or something. But the reason why we're able to get away with that, another reason is because even if you have 100,000 rows in your customer table, and you may have, a K of data, how big is that? That's 100 megabytes. That's not very much for a dimension table. If we're taking the information that there's actually a lot of, that's your transaction information. That's the fact tables, the numbers. If you had 100,000 people in your customer table, how many sales transactions do you think you would have? Millions, billions of sales records. If you have 100,000 customers, they're going to be doing a lot of transactions with you, just given that volume. There's going to be zillions of them. So in that kind of a table, we really want to squeeze it thin. We want to use the smallest data type we can, store the least amount of data that we can in that file, and still deliver to the users. But all that's just numbers. And we actually use surrogate keys to get back, and we don't want to use character keys to relate it back to those dimensions so that we can do that slicing and filtering and things like that. So we try and thin up those fact tables as much as possible, but fatten up the dimension tables. Okay, because the dimension tables are what the business users are going to use to drill into that data in order to pick things out. They're not looking at the individual numbers in the fact table. Those are always getting aggregated. Okay, so it's okay to make that thin, but the dimension tables we want to get really wide. So if you're interested in delivering BI in your organization, we went over those critical success factors, some of them, which mostly had to do with a business, but I want to give you something a little more specific. Your goal for doing BI in your organization should be to enable better decisions. We talked about that at the start, those 7 rights, or however many you want to tack onto that sentence. The right price for the right customer at the right time. Those are the kinds of decisions you want to help your business people be able to make. A little bit faster than they do now, a little bit better than they do now. But that's what this whole thing is for. This is not for any other purpose than that. They need to get value out of it, and that's the value they're going to get, or that's the value they should get. Unfortunately, it's not about acquiring cool technology. I know we all like some, and some of it comes along with it, but that's not the goal. That happens sometimes. You might get a cool column store database that you can play with, or a new 8-way box that you can play with. But that's not why you should be doing this, and that's not the end all for you. At the start, I talked about IT being a service organization that has to serve the business users. When they come and say, I need some of this information, your first thought in your mind shouldn't be, what piece of hardware can I go get? It should be, how can I get him what he wants? How, by hook or by crook, how can I get it to him? Okay? But since we're all techies, we're going to be wanting to know about the technology end of it, and one thing which I hope you can get, and please question me if you have any other questions about why an OLTP system is not appropriate for this kind of data use. Sure, you can do it, but it's probably not what you would want to do. I hope I gave you some reasons for that, but if you still have some questions, please ask them anytime. The dimensional model of structuring information is the way to go about doing these things, even if it goes completely against the grain of everything you've ever learned about databases, about them being normalized, about not duplicating information, about trying to store it in as little space as possible. Some of that, because of the way that the business intelligence and data warehouse is used, is no longer important. It's much more valuable to take the time and to take the space to store more information, to store it in the format, that star schema format, than it is to try and be efficient. Because when you're dealing with an OLTP system, that efficiency is just for the application program. It's just for your hardware. Users aren't using that data. Users are using that application for your line of business system. In a data warehouse and business intelligence, people are using that data directly. Sometimes they don't appear to be because they've got a cheery little graph on top. But if they want to filter that chart to only North American sales, again, you don't want to have them picking NA. You want to have them picking North America. Because who knows, maybe they're picking a state. They don't know. That's context again. You need to have some context provided with that, something English that these business types understand. They give us a hard time, we can give them a hard time sometimes, right? Okay, so the way that you would go about doing that is, number one, you need to involve some business users. This is something that I am personally going through. I have to find some more people that are interested in my company. 2 years ago, I went down to the Microsoft Business Intelligence Conference in Seattle because I thought it would be a neat thing. I didn't know about data warehousing. I didn't know about business intelligence. And this is the kind of stuff that I learned there, is that it doesn't matter what I know about the technology or what benefits I think can deliver to the organization. I can't push it on them. They have to want it. I can try and explain to them the kind of things that I've tried to explain to you today, the difference between data and information, and how it might be able to help them make better and faster and more accurate decisions. But they're going to have to come back to me and say, okay, I like that concept. What is it? Can you do this? Can you give me this information? Because I need to make sure, like I had in that example, that I'm not giving money away or that I'm not charging a customer too much. That's my problem as a business guy. Can you help me? Can you give me information that will solve that problem? If they ask that question, they already know the business value of that question. And therefore, they already know the business value almost in dollars, and you probably press them a little bit, what the business value in dollars is on delivering an answer to that. And that'll probably pay for all the hardware you need if they were willing to give it all to you. So probably not. The other things you're going to have to do is, of course, acquire the skills and the technology to do it. That's the easy part for us. And one of the more important parts is developing it with the business incrementally. There's a track on Agile here today, and I don't know if anybody's been to any of those sessions, but Agile is a way which we can get at doing this in a way that's comfortable for the business users. Remember what I said about you'll give them a report, and they'll take a look at it for 5 minutes, and they'll go, that's great, and I'll never look at it again because now that I've seen that information and I can understand a little bit more about my business, that's no longer information that I need. I need this information. But they would never be able to ask you for that second report had they not seen the first. It's an iterative process that you're going to have to go through. You're going to have to give them a little information, know that they're going to throw it away and ask you for something different. Get that, throw it away, and ask for something different. Basically, aside from the throwing away part, that's Agile. Iterations, going through and getting closer and closer to what it is that they really want to see, because they don't know.
I think sometimes you have to require something that's very customer level. Like, for example, if you go to Safeway, they've got club points, and 50s, they've got cards. Basically, they want to tag the customer with what they bought.
That's right. That's a good point. I mean, there's a lot of customer loyalty programs out there. The airlines have it with their points programs. The shopping markets have it. You can go into, say, Eddie Bauer and Starbucks, and they've all got their little cards, and it's a customer loyalty program. And I can't remember where I heard this, but I think it was when the airlines started doing this, and I don't know if it's still the case today, but they make more money off of their customer loyalty programs than they do off their flights. Yeah. They make tons of money selling that information to other people, selling the analysis off that. And the reason they make all that money, the reason why it's so valuable is because people want to know about what you want to buy. They do that data mining on it, right? So they're trying to get information out of that data. The reason they have those customer loyalty programs is so that they can tie those individual invoice line items, those individual sales transactions to a single person. Without that, all they can do is make generalizations about the market and think that, well, on average, we think that this product's going to sell a little better. But one of the interesting things that you can find out in a loyalty program, specifically in a supermarket, how many people have heard about the beer and diapers story? I think this is true. It's almost too funny to not be to be true, but I think it is true. Basically what happened was that it was a grocery store, and it's obviously in the States because there's no store that would sell beer and diapers in Canada together. But they found through their customer loyalty cards and programs, they did what's called a shopping basket analysis. Is that for a single person who's buying something, what things are in their shopping basket at the same time? It's kind of the same thing when we're talking about Amazon, about if you're buying this, you probably want to buy this. But they just said what's in their shopping basket at the same time, and they found that late at night, when they sold diapers, they sold beer at the same time. More so than in the day. They couldn't figure this out for a while. They moved the beer display closer to the diapers, and they sold more of both. And they had they really didn't know why until they started talking to the people who were buying them. And it turns out it was guys coming in late at night because they had to buy diapers for their kids because the mom was at home taking care of the baby or whatnot. And at the same time, they're like, well, might as well make this trip count for me. And they'd pick up some beer at the same time. So they moved the beer a little closer to the diapers. Right? That's the kind of thing that no business person without that information, that analysis, would ever think of doing, even if it's something they did. Even if they had a little kid at home and every once in a while they go to the grocery store and pick up some beer and diapers at the same time, it's just not something that fits in your head at the same time. But that's the kind of thing you can expose, some of the patterns you can expose by doing some data mining, some things like that. And a lot of this is terribly automated. You can just say, here's my sales data, and throw it over to a data mining thing, and it will pick up these relationships and say, hey, did you know that people who bought diapers also buy a lot of beer? And you may be able to take a look at that and go, that's just an artifact. That doesn't really happen. But you really should probably test it first. Right? So that's pretty important. And doing that incrementally with customers is part of what they did there as well, is that they found this pattern in data. And then they talked to the business, or the business took a look at that data and said, I think we have to test this. So let's move the beer a little closer to the diapers. Let's start doing some customer surveys. Why is it that you're buying beer at the same time you're buying diapers? Okay. That could be another explanation. Awful small diapers, though. Yeah, there's a lot more out there to learn about business intelligence and data warehousing. And a good deal of it is very local. Okay. There's a couple things on the business intelligence end. Dr. Robert Kaplan and was Norton, or no, somebody Norton, who developed the balanced scorecard. Reading about them is really very good from a business point of view, about figuring out how it is that you can align your business strategy with what people do every day. A scorecard's very good for that. Stephen Few is a guy who's written a book called Effective Dashboard Design. It's excellent. If you remember that little graph, that scatter plot that I made, didn't even really need the dollar amounts on it, or the percentages and the dollar values. That's the kind of thing he's talking about, is the visualization. That some things that the human visual processing system automatically picks up on, some patterns and things like that, that automatically tell the person looking at it what they want to see before they even know they see it. And putting a whole bunch of numbers on a page doesn't do that. But good use of color and actually removing a lot of visual elements from the page does allow people to pick up very quickly on what you want to convey. And so Stephen Few's got a good book on that one. On data warehousing, I tend to subscribe to the Ralph Kimball way of doing things. That's why I talked about the dimensional model. There's a couple other people out there, Bill Inman, Claudia Imhoff. who espouse a little different way of putting stuff together. Either one is, they're talking about basically delivering the same thing in the end to the business user, that business intelligence, the way they go about it in the middle step in that data warehouse part of it, and they have a different term for data warehouse too, but that may be a little different, but they're all going for the same end, and they do both have very good ideas. The good news, very good news here is you've got a lot of local resources. Number one, you came to this event, which is good, but there's a lot of other chapters and user groups in the area that have a lot of information on this kind of thing. We have 2 past chapters in Vancouver. That's the Professional Association for SQL Server. And since Microsoft has a stack, that's what they call a stack of BI and data warehousing tools, that's some of the things that get talked about in SQL Server. And there's 2 of them. One's a regular, what I call a DBA chapter, and we've got another one, a BI chapter, which Scott runs. And so if you're interested in that, talk to Scott. There's also PASS is a global organization. They do a whole bunch of stuff. There's hundreds of chapters in North America, I think. Probably over 100, I don't know.
200 chapters, or 100 in North America.
100 in North America. There's some in Europe and everywhere. They also started doing virtual chapters, and one of those is on business intelligence. And they have several, or they have been having several virtual meetings a month where it's just a webcast for an hour and a quarter, where some guy will, one of the MVPs or whatnot will come in and talk about data cleansing or dimensional modeling or using SQL Server analysis services or reporting, something like that. So those are very easy to get, and they usually have recorded webcasts available too. And of course, all that's free. No cost to you to join or anything like that. There's also a TDWI chapter in Vancouver, the Data Warehousing Institute. And they're also very good. They're more technology agnostic. They don't, the past chapters is really kind of a Microsoft-centric one. TDWI is vendor non-specific. They just recently, it was a couple months ago, had a guy come in talk about visualization, the Stephen Few type stuff. It was very interesting. We've got the SQL Server World User Group, which is an entirely virtual thing. They got a website, and they have conferences, virtual conferences. They tape a couple presenters, and you pay $100 for a full day of conferences. That's it. It's kind of regular conference quality stuff, except it's all delivered over the internet. And then, of course, we have some actual real physical conferences, kind of like this one, but bigger. The past conference yearly in Seattle just happened a couple weeks ago. It was fantastic. 2,500 SQL Server professionals, almost half of them talking about business intelligence and data warehousing. It's become that big, and it surprised a lot of the traditional database people that BI is that big, but they shouldn't be surprised. This upcoming year in 2010, Microsoft's going to have another BI conference. I went to the first 2 of those, and they were both very good. I liked the first one a lot better than the second, but they were both very good. They have a lot of introductory sessions, and of course, they've got a lot of advanced sessions and everything in between, too. And of course, since it's in Seattle, they've got all the Microsoft people there coming to talk about it, answer questions, everything. And you're going to have there was over 100 MVPs there. There was 400 Microsoft employees to answer questions. Both of those were great. And that's it for today. So I'll back up one slide, and if you have any questions at all, fire away.
What happens when the normal transactional databases that you can too much changes as business change?
Yes.
What happens in the AI world?
Well, a lot of times the question is, in your line of business system, you'll have schema changes in the data because the needs of the business change. They'll have a new government requirement, or they'll want to capture some more information or something like that. A lot of times what happens is that that's really not relevant when you're talking about a data warehouse. Because a lot of the time that happens, it's a procedural thing within the company as to how to service the customer. You at least have a chance there that it's not going to have any impact on the result. Was the sale made? Who was the sale made to? And all that kind of stuff. Sometimes you may have something where you're now tracking a different attribute of a customer. You want to know whether they also shop at your competitor. And now you have a way of collecting that information. You've told your sales guys to ask on the phone, have you shopped at our competitor lately? And they record that information. And you want to push that through the data warehouse. There's a stage to this whole data warehousing thing. You've got your OLTP system over here, and you got your data warehouse over here. Well, you got to have something that pulls, actually you probably have more than one OLTP system over here. You've got to get that information over in your data warehouse. And the process of doing that is called extract, transform, and load. A big term for that. But basically, it's just bringing that data into the dimensional format. And sometimes it's going to require schema change in your dimensional model. But the same way which you manage that change when you're dealing with an OLTP system, one of the good ways to do that is with views. You can do exactly the same thing with your data warehouse. Put a set of views over the raw tables. And most of the time, we're talking about the same kind of tables, same host. SQL Server, just holding dimensional model in tables just as your OLTP system might be using SQL Server to hold normalized tables. Still the same tables, you slap views on top of them and have any BI tools go with the views instead. So you can change the underlying data schema, leave the view alone, and then use possibly some lineage tools to figure out, okay, who's using this information, and if we add a field or we change the nature of a field, is that going to screw, who's that going to screw up, and go through your QA and test and all that other kind of stuff to manage that change. Then there's also the big question of, okay, well, now that we've changed that, what do we do with all the historical data? Right? Usually the problem there is a really easy one to solve, because if you've got a dimensional table, again, it's your customer table, and it's really wide, and now you've got this new attribute on it, do they shop at our competitors? In a OLTP system, most of the time, since you've never asked that question, your OLTP system is going to have a table, it's going to be filled with nulls. Business users don't understand null. It's hard enough for us to understand it. Okay? Don't ever put a null in a data warehouse, whether it's for an attribute, a fact, anything. Business users don't understand nulls. Behavior of averages over nulls is scary to explain. Where does null fit in? How do I get all the people that have never answered that question? Where that is null? That doesn't mean something to a guy who's used to dollars and cents and customers and all that kind of stuff. So when you take that stuff, now that you've got that extra table in there, you're probably going to go and have to add that extra field to your data warehouse, and you're going to fill it with a dummy value of haven't asked this question yet. And it's okay to stick something that long in there, because again, you've only got 100,000 rows. It's really not that much space to have 100 megabytes on your system to hold that information. So you can have something that big, and then they can actually drag that out with use Excel pivot charts and pivot tables and pull out, do they work for a competitor? It'll have three values. Sorry, do they buy from the competitor? It'll have three values, yes, no, and I don't know. And they can pull all three of those out. Because they may want to know, are my salespeople actually asking this question? Has that answer changed over time? You can even start to track that question over time if you wanted to. I don't know what value is in that, but I don't run the business. So you can't assume that there's value in something. You have to ask. But that's what's going to happen. You're going to have your sales guys putting in this new question because the business guys told them you need to ask them if they shop at our competitors. And then they're going to come see you and go, I need to see that data on some reports. They need to tie that together. So it is another system you're going to have to make a change to, but it should be manageable.
What about if it's a new measurement?
If it's a new measurement, that all depends on what kind of a new measurement it is. It could be a brand new fact table. And most of the time, I would probably suggest that it's going to be, because it's going to be a different business process which they're going to be collecting information off of. And usually you have one fact table per business process. You're going to have a fact table which contains stuff related to the line items on an invoice, the actual sale, the recording of the sale. You're going to have a different fact table which records the state of your inventory. Those two fact tables, which contain things you can add up, may be related to each other, but not directly, because there's nothing in those. There's just numbers. They're going to be related, each one individually, to a date of when you took that inventory measurement, of when you recorded those sales. They may be recorded to a warehouse. The sale was delivered from this warehouse. That's the inventory in this warehouse. Right? So you can that's called drilling across. When you say, we made all these sales that day, what did that do to my inventory? You can drill across and find out. Okay, so typically different business processes are going to have different fact tables. Any other questions? I don't know what we've got for time here. About 5 minutes. Thank you very much. I hope you've learned something. Thank you.